Good morning, my name is Alejandro Pegabarón. I am going to tell about the effect of fly ash additive on the resistance of concrete to alkali silicate reaction. The alkali silicate reaction is one of the most demanding reactions in concrete. Also, is affected by many factors such as nature, binder, reactive aggregates. These methods also related the makes cracking of the concrete structure resulting from the expansion of the reactant product of alkaline silica easier calcium hydroxyliquid hail. These easier damage are the result of the combination of three essential components: reactive silica, alkalis, and moisture. The object of investigation is an improved concrete model resistant to easier with fly ash to achieve the objective. The effect of fly ash on concrete properties is analyzed on the dependence between its quantity, the change in speed and expansion of the ultrasamples wide with aggregates contaminated with reactive particles is determined, as well as evaluating the effect to the easier process in structure and property of concrete. Extending the duration of the investigation from 40 to 56 days with sample of 3, 7, 40, 28, 56, 91, and 365 days of coring. Materials such as Portland cement, fly ash, sand, and water were used, explained in Table 1, Table 2, Table 3, and Table 4. Table 1 shows the physical cement, chemical properties of cement. Table 2, chemical and mineral character of cement, which on the right, and Table 3, with chemical and mineral character of fly, which is on the left. Table 4, physical property of sand, and finally Table 5 on power flow superplastic air features. Material here's some image of the fly those microstructure presented in the figure are presented. The image is dominated by regular superfly and parts as particles magnet mining 500 times figure A. The main particle is the image magnified in 3000 times figure B reveals the same thing. The finest particles have the regular shapes of cement balls. Fly modified concrete samples have a lower water absorption rate. The test results are present in this figure. When the general additive content is increased to 65% maximum, the absorption rate increase 3.673, which means that the fly ash content is excessive in terms of weight absorption. Inspection results were appointed after raising concrete spacing modified with fly ash additive after 56 days of coring. The test result revealed that the critical expansion limit of 0.1 percentage was exceeded only when 50 percentage of the fly as was used. The registered expansion value was 0.105 percentage. The expansion limit is not exceeded for the other lots. And the modified concrete structure is illustrated. Control sample. The figure illustrates mineral 3 concrete structure examined by the common electron microscope. Alkaline hell ledgers are visible around the aggregate in easier effect concrete without mineral additive. The ledgers at hell absorbed water and begin to expand, which causes the development of cracks in the cement matrix. A gap is also visible between the aggregate and the hell, a product of the alkaline silica reaction. This figure illustrates the same image of the microstructure of the sample containing the maximum amount of fly ash and conditioned solution at 84-56 days. The contact zone between the aggregate and the bonding material appears strong in the microstructure of the 65% fly ash modified concrete. There are no gaps or signs of break. The matrix cement has no crack damage, which are characteristic of surface affected by easier. The image presented in the following figure show fly ash particle visible in the hardened cement post. This reaction restricts the formation of alkaline silica hell in the contact zone between the aggregates and the binder material, and such concrete becomes resistant to easier. And finally, in this figure, the expansion rate does not exceed the allowed expansion of the limit. value of 0.1 percentage after condition in a sodium hydroxide solution at 84 56 days, and said concrete is resistant to ECR. And to conclude, the revealed that 65% fly-ash modified concrete has better durability and reacts to alkaline silica corrosion resistance characteristics and can be used in a construction sites.